let's write the equation for this graph right here. This graph right here, you should know it's a polynomial, and it's an odd degree polynomial that has an a value that's positive. How I know that is it starts low and it ends high. That means it's odd degree, and because it's starting low and ending high, it's also a positive a value. So I'm going to write my function y equals, and I know my a value is positive, so I don't need to worry about putting a negative value in the front. So I know it's positive. Now my 0 is right here. Remember, my first 0 is at -1. So the opposite of -1 is +1. So I'm going to write that at x plus 1. That's my first factor. My first factor is x plus 1. My first 0 would be a -1, always the opposites. My next one is 0. Now, instead of putting x plus 0 or x minus 0, I'm just simply going to put x. I don't need to put x plus or minus 0. It's kind of pointless. My next 0 is +2, so the opposite of +2 is x minus 2. And the last 0 is at 3, so the opposite of 3 is -3, so it's x minus 3. So what we have here is a intercept form, also called factored form, equation of this polynomial. All right, now the problem is how these zeros happen. You have to be careful because each of these has a specific power depending on how it crosses or intersects or how the intersection is. Each 0 is behavior. So here in the -1, look at the behavior. Do you see how the graph goes through but with a little bit of a twist? Call this a through with a twist. Well, if your graph goes through with a twist, the power for that 0 has to be bigger than 1 and an odd power. So for this one, my power is going to be bigger than 1 and odd. So the next odd power would be a 3. So that's going to be a third power. All right, this one is just a straight through, no twist or anything. So that's just going to be a power of 1. I don't need to put a power of 1, so leave that. Again, whenever it goes straight through without a twist, it's just a power of 1. Okay, when it has a twist, it's something bigger than 1, and it's odd. So I could have put a fifth power there if I wanted to. All right, here at 2, my x-intercept of 2, well, whenever it bounces off, that's an even power. So a good, easy, even power would be a 2, a squared. Again, it could have been a fourth or a sixth. But whenever it bounces off, it's a even power. And over here, you can see this intercept goes straight through with no twist or anything. So that would just be a 1. So these two have a power of 1 for sure. And this could be any even power, and this can be any odd power bigger than 1. Now, we don't put negative powers on these. That would make it a completely different type of graph. So if we were to FOIL this out, which would be a big nightmare, you would end up with a very high degree. It's an odd degree polynomial. Now, how do I know what degree polynomial it would be? Well, you just add the powers, meaning 3 plus 1 plus 2 plus 1 would be 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 1 is 7. So if you really want to think about it, this is going to be a 7th degree polynomial. Okay, a 7th degree polynomial, this would be a particular possible equation for this. Now, how do we find the exact a value? That's a whole other story we're not going to go with. We're just worrying about these zeros and the behavior of how they intersect the x-axis. And we do know, again, that the value in front is positive for sure. We just don't know the actual value of the a value to get the exact equation. I know it says the equation. We found an equation here, not the exact one. And again, it's a 7th degree polynomial. If you wanted to FOIL this out, have fun. It would be x to the 7th power as the degree. Alrighty, let's sketch this polynomial function in intercept form, also called factor form. Alright, so the first step is to look at the zeros. Let's plot each 0. So this 0 right here is -4. So let's put a dot -4. Alright, this one, the opposite of 1 is -1. So I'll plot a 0 at -1. And the last one, this -2, would be a +2, 0. So I'll put a dot at +2. Now I want to make the function for this. Now the question first is, what kind of degree is this? It's important to look at the degree of this. Well, you find the degree by adding the powers. So 3 plus 2 plus 1 would be again you have, that would be 3 plus 2 plus 1 would be a 6. So that means it's a 6th degree polynomial. Now, your a value is -1. Now, so if this is a 6th degree polynomial and the a value is -1, well, 6th degree means it's even. And it's a negative, so it's upside down. So this graph will look something, I don't know how the humps will look, but it'll look something like that, where the graph will, both sides will be going down because it's negative, and it will have this M-ish look. Now it could have more humps, because the 6 could have a whole bunch of humps. But for now, this is what we generally are going to look like. So what I mean by that is I know the graph, this side of this red dot is going to go under, and I know it's also going to go under here. So now the edges are going down on both sides. So let's kind of sketch and think about what it's going to look like. I also know that at -4, I know it's going through, straight through here. Here it's going to be, because it's squared, it's going to be bouncing off here at -1. And I know it's going to go through here at 2, but with a twist. So this is going to be kind of tricky a little bit. And the best way I think to start this is to look at the edges. Again, we said the edges are going down. So let's quickly just kind of make a sketch. I know this is going to be going down like that on each edge. So somehow it's going to be going down. Now the thing is, on this edge, I knew, on the left edge, I knew it's going straight through. So I can just make a straight through, okay, down right there. But on this edge, I know it's going down, but I know there's going to be a twist and a through. Again, because the odd power means through, and it's bigger than 1, so it's a twist. So what would a twist and a through look like? Well, what that means is it's going to kind of probably come down, twist through like that, and go down like that. Sorry, my graph isn't very pretty, but it goes through with a twist. Let me get that x-intercept a little bit clearer. Put that one a little bit better. So, as you can tell, both edges are going down. I just know this through is a twist, and this one goes straight through because it is a 1 power. Now I know right here it's going to hit a bounce off. So if you look at these two graphs, see these two edges? Well, that means it's going to kind of go like this, up, bounce off, and come back up like this. So that's how I kind of can guess this middle one, because I know it's a bounce. It would make no sense to bounce off the bottom, because then it would have to cross the x-axis again, and we don't have any x-intercepts between here. So I know from this dot to this dot, it's got to stay above the x-axis, because there's no more possible intersections. So I'm going to go up. I'm going to go up right here. I don't know exactly how high. Then it's going to come back down, bounce off that, go back up, and there we go. So we know the intercepts. Let's see if it worked. Did we go through at -4? Did we bounce off at -1? And did we go through with the twist at +2? Does it look kind of like this? Kind of good. And boom, we got the graph, or a possible sketch. Again, this is a sketch because we don't know the exact a value of that function.